Bismillahirrahmanirrahim. Assalamu alaikum. Today we have another interesting exercise and a visual exercise in which we can see the industrial environment, how we can control the production process and how we can see the programming of a industrial process. For this purpose, in this exercise, we have to control a conveyor belt in such a way that there is a silo which is filled with a material, maybe water or something else, liquid, which is this silo is filled with this material or liquid. When the block comes right under the silo, at that time this proximity sensor senses the block and it at that time stops this belt motor, and the belt will be stopped and this silo starts opening and there is a valve which starts opening, and at that time valve will be opened and the level sensor also will be active. It will check the level of the material which is being filled in the block. When the block is full with this material, it again starts the belt, and at that time this motor will again start. When this belt will be moving, at that time the run light will be on. When this block is stopped, at that time the fill light will be on. When the block is full with the material, at that time the full light will blink and again the run light will start on because the belt will be started again. When we press the stop button, this block and this belt should be stopped at its position. When we press the start button, the process should start moving. So, how we can program this process? Let us see and make a program in this Logix Pro. So there is a programming window in front of us. We can program here. We can make a program here. First of all, we will take the start button with normally open contact. This start button is this one because this one is normally open and this is a start button. So we will use the address of this button, drag this address and leave this address here on the contact, which is input for the motor. At the output we will use the belt motor, which is we can also write here what this thing is, a date symbol, right here, start button. So this is the start button, and at the output we have a motor. This is the motor of the belt. So drag its address and place here on the output. This is the output motor. We can write here, this is what this is. This is the belt motor. Yeah, you can also say it is the belt. At that time, when the motor is on, the solenoid valve should be off and the stop button should also be closed. So we will use here the solenoid valve, normally closed condition. This is solenoid valve, and solenoid valve is, its address is 2/1. We can drag its address here, 2/1. It is normally closed, and at the same time the stop button should also be used, but we can see that stop button is normally closed. It is internally closed. If we use the normally open contact here, it will again show that it is internally closed. So it is internally closed. Stop button. Stop button. This address is I1 over 1. We can use here. When these both of these two, what is this? We can write its name here. Edit symbol. What is it? Solenoid valve. Solenoid valve. This is solenoid valve. And the other thing is stop push button hai. Edit stop. This is the stop push button. We can also use, we will use here the normally open contact of this belt motor, because when it starts, it should be moving due to latching. So we can use the latching process, latching application here. And latching will be with the output motor. It's normally open contact will be used here for latching process, latching purpose. So this is the contact of the motor. At the same time, we will use the full light here. I will tell you later when we use the full light, which is here. Its address is 2 or 4. When the block becomes full with the material, this should be on and solenoid valve should be off. For this purpose, we are using here the contact of this full light 2 or 4. When solenoid valve is off and at that time stop button is also normally closed, we should have belt moving because the valve is stopped. Material is not coming down onto the belt, and at that time this is out. This is the normal open contact of the this output light. It should be closed and the belt should start moving forward. We can also use here the contact of full light. We can also use here the contact of the full light, 2 or 4. Its address is 2 or 4. Here we can drag its address and write here. This is the full light. I should write here its name so that we can easily understand what this thing is. Full light. Both these two things are same. This is the normally open contact of the full light, which we will have here, which we have here. After that, if proximity sensor detects the block here, the solenoid valve should be on. Proximity sensor is this one. I'm using here proximity sensor. Its address is I1 over 3. I can drag its address right here, and this is I1 over 3 proximity sensor. I can also write here proximity. Proximity sensor. If it detects that there is a block, it should stop the motor so that belt will be started, so that belt should be stopped here, right in uh, right near, very close to the silo. At that time, solenoid valve should be on. Solenoid valve is out O2 or 1. So we will have solenoid valve should be on with the proximity sensor. But at the same time, the full light should remain off. So we will use the normally close contact of the full light. It should be off at that time. When the full light is off, it means there is the light of fill which is on at this moment. Again, level sensor becomes active, and there is a level sensor. This level sensor becomes active. We will use it here. Its address is I1 over 4. We can drag its address to its position and write here level sensor. This is level sensor. When it detects the level, that it is full, the full light should be on. Full light, this is the full light. Its address is O2 or 4. We can drag its address here, full light. It will be on. But at the same time, proximity sensor should be on. Proximity sensor should remain on. It is quite clear that when the proximity sensor detects the block, it should open the valve, and at the same time, when the level sensor detects the level of the this block, that it is completely filled with the material, it should start the belt again, and proximity sensor and this valve should be closed, off. So level sensor and proximity sensor. I can also use here proximity sensor. Proximity sensor is I1 over 3. Its address can be used in this way. You should drag the address from one point to the other point, and it can work very easily for you. And we can also use here the latching of this full light. It should remain on. When the block is full with the material. After that, when it is filled with the material, its output will be energized, and full light is its contact will be closed here, and there is a path for the flow of current, and the belt will start again. But the proximity sensor is stopped. That's why the full light will be stopped, because when it detects that the level is full, the full light will be energized, its contact is closed here, and the output motor, the belt motor, will start, and the proximity sensor again becomes deactive. So belt start, when the belt starts, its normally open contact will be closed. Two or 0, this is the belt motor. When it starts, run light should be on with it. Run light, because you You can use here the run light. This is the light and its address is here O202. You can use its address here and right here run light. So this is the run light. When the belt starts its motion, the run light should be on with it, along with it. And solenoid valve, when it is on, means it is allowing the material to go to the block. At that time, solenoid valve, its address is 2 or 1. We can drag its address here. This is solenoid valve, and output is fill light. You can use the light of fill. Its address is O2 or 3. Drag its address here and right here fill light. So in this way, now we have completed the program. We can test it whether it is working or not. Whether it is true or not. So first of all, we will download this program to the PLC and then press the run button. Now we can press, if we press the start button, this belt should start and block should be moving forward. When block comes near to the silo, it should stop the belt and allow the valve to and open the valve, which will allow the material go into the block. And when block is filled with the material, level sensor becomes active and it again starts the block. When the belt is moving, the run light should be on. When the block is being filled with the material, fill light should be on. When it is filled with completely, then full light should blink once and then again the belt should start its motion. So we started this exercise, press the start button. You can see blocks are coming quite rapidly and are being filled with the material and are moving to its end. You can see the blocks coming rapidly, easily to the silo and are being filled with the material and are again moving forward. We can stop it. If you press the stop button, it will be stopped here. Yes. If I press the stop button, this belt will be stopped, and because this is the stop button, it is normally closed. When I press it, it will become open and the belt will be off. Again, if I press the start button, blocks will be coming and will be filled with the material and the process will continue. So this is how we can program an industrial process for filling of bags, or filling of the packets, and these packets are filled with the material and are delivered to the end for the packing. So this is quite helpful exercise for you. If you want to learn this exercise and other exercises, you can tune to YouTube channel Technology Reveals. Subscribe this channel. On this channel you can see the automation related videos, PLC programming, HMI design and SCADA development, which will help you in building your career, and it will also help you making your professional career in the automation field. It will improve your knowledge, your skills will be improved, and you can easily hunt a job for yourself. Thank you so much for watching.